Okay, so let's wrap up our radical conversation by taking a look at some equations that involve two radicals. So remember, the game plan, like we saw above, is to get the radical by itself and then raise both sides to a power to get rid of it and then solve the resulting equation. Well, the same thing's going to be here. We're just going to have to do it twice. So in the first round, you probably want to just pick one that you can isolate relatively easy. And so perhaps maybe what I begin with here is adding to both sides the square root of x minus 5. That results in my new equivalent equation, the square root of x plus 4 equals 1 plus the square root of x minus 5. And now that we have one of these isolated, to get rid of that radical, we're going to square it, and then to be balanced, I have to square the other side. And then, of course, here's where we have to be careful. On this side, we're squaring a radical, so it goes away, so that's the good news. And on this side, though, we're squaring a sum. Just like we were squaring a sum here, or we were squaring a difference there, right? It's not as simple as squaring each piece and then subtracting or adding. What we have to do is FOIL it out, all right? So that's what it means to square that. So we got a nice FOIL process. Again, it's going to be your perfect square trinomial. So first times first is first, right? And then if we look at the outer and the inner, they're both the square root of x minus 5, right? So there's 1, times the, well, let me just go ahead and write it, right? And then we're going to get another one. And then last, we're going to get the square root times the square root, right? So we're going to get that. Okay, so there's literally the FOIL process. And what we end up seeing at this stage of the game is these two combine because they're the same radical. And then over here, the radical clears itself out. Okay, so the good news is we got rid of one of our radicals. The bad news is we have now an equation with another radical in it. So we basically just follow the same routine yet again. So, in this case, I'm just going to keep it the way it is. I'm going to subtract x from both sides. I'm going to subtract 1 from both sides. And I'm going to add 5 from both sides. So there's all the balancing act that I do. When I finish that off, the x's cancel out over here. Right, 4, take away 1 plus 5, I believe is going to give us 8. And then we have 2 times the square root of x minus 5. And in the spirit of continuing to isolate it, right, what we end up with is x minus 5 equals 8, or excuse me, equals 4, right, all the way back up here. And then we square again, and we get x minus 5 equals 16. Add 5 to both sides, and we get x equals 21 as a potential answer. Of course, now what we have to do is check it. So 21 plus 4 would give us the square root of 25. All right, 21 take away 5 would give us the square root of 16. This would be 5 minus 4, which is 1. So it actually does check out. So after all that work, right, good news is the value that we got actually does in fact work. So that is how you solve an equation with two radicals in it. You isolate one, do all the work, be careful about your foiling out, right? And then once you've done that, you isolate the second one. And again, just showing my balancing acts. I don't know if I've said this enough, but the way that I show the work is the way that I actually want you guys to show your work on quizzes. So, you can try to keep it down to one page in terms of turning things in on quizzes, but you can see that I'm able to accomplish that. Right now I've done, what, 1, 2, 3, 4, 5, 6, 7. I've done 7 problems all on one page. So write a little small, hopefully my writing is relatively clear. Show me your balancing acts, all right? That's how you're going to show me your work and get full credit. Okay, but at any rate, right, we have another one. Again, probably the best way to isolate this one, right, is to add the square root of 3x plus 4 on both sides. That gives us the new equation, the square root of x plus 2, 2 plus the square root of 3x plus 4. So to get rid of this radical, I'll square this side, and to be in balance, I have to square that side. So we have x plus 2, and then again, we're squaring a sum. So that means I have to multiply this to itself. All right, so we have x plus 2, and then we're foiling. 2 times 2 is 2. When I do the outer, I get a 2 square roots of 3x plus 4. When I do the inner, I get another 2 square root of 3x plus 4. And then when I multiply the last to the last, I get the square root of 3x plus 4 squared. Okay, so there's our FOIL process. Cleaning this up, we have x plus 2 over here. We have 2. These two combine up to 4 times the square root of 3x plus 4. The radical clears out and we're left with 3x plus 4. So in essence, we have to simplify this. So we'll subtract 2, subtract 3x, and subtract 4, which means I subtract 3x, subtract 2, and subtract 4 on that side. So when all is said and done, I believe we end up with negative 2x minus 4, right, equals 4, the square root of 3x plus 4. Okay, so there's basically what our work looks like. And then at this stage of the game, right, what we have is to get rid of this radical, we could divide by 4, but I'm going to avoid doing that because I'm going to end up with a fraction on this side. So how about I just square both sides, and I'll point out something. Over here, we basically have a FOIL process because we're squaring a difference, but over here we're squaring a product. So when I'm squaring a product, that's when it's okay, because there is a rule that when you square a product, right, you square each piece. So we get 16, and then when I square that, we end up with 3x plus 4. So over here we FOIL out. We get 4x squared, I believe, plus 8x, plus 8x, plus 16. And over here we get 48x plus 64. Alrighty, so what we end up having in this case, after we finally got rid of all those radicals, right? What a train wreck, huh? What we end up with is a quadratic to solve. So the way we solve a quadratic, let me go ahead and continue to kind of simplify here, is we set one side equal to 0. So I'll subtract 48x from both sides, and I'll subtract 64 from both sides. And I'm hoping that this thing factors. So we end up with 4x squared minus, I believe that'll be 832x, and that'll be a 48 equals 0. If I divide everybody by 4, we end up with x squared minus 8x minus 16, or excuse me, 12 equals 0. Okay, and so there's basically our solution at the moment. All right, let me make sure I got all my signs right. Minus, minus. Yep, everything looks good. And so now we have to solve this quadratic. What I'm going to choose to do is solve this quadratic. Let me add 12 to both sides by completing the square. So negative 8 gives us negative 4, negative square root of 16. So x squared minus 8x plus 16 equals 12 plus 16. So over here we end up with x minus 4 squared, and over here we end up with 28. Okay, taking the square of both sides, plus and minus, we have x minus 4 equals plus or minus 28. Add 4 to both sides and simplify this, right? This is 4 times 7. So we end up with x equals 4 plus or minus 2 square roots of 7. So that is a pretty crazy problem. I wrapped up things here. We have just about everything we've probably learned in our course up to this point, or relearned, right? The new idea of isolating radicals to get rid of them, right? The golden rule of squaring both sides, FOILing out, right? The difference between squaring a sum or a difference versus the difference of squaring a product, solving a quadratic, right? And then solving that quadratic using our completing the square process. The only thing that would be left is to prove that these two are actually working, and that's probably where we're going to turn to a calculator at this point. So I'm going to stop there. I believe one of these works and one of them doesn't, but we'll actually do a check next week when I actually put a graphing calculator in your hand. We'll redo this problem on a graphical nature, and we'll kind of get a feel for which one it is. However, what's nice about the algebra is I have exact answers. The calculator is going to give us a decimal answer. But let me go ahead and stop there. Obviously, you guys probably have to pause and rewind so you can kind of check some of those steps. That one's on steroids. That's almost like a finals problem, so it has everything in there. So that wraps up our radical information, how to solve radicals. Of course, in this section, we've got 3 more, absolute values and hidden quadratics. So I'll see you in some future videos when we take a look at each one of those cases individually. Talk to you guys later.